to the right, we have the graph of f of x equals, in the numerator, the square root of x plus 9 minus 3 all over x. And this graph shows that if I try to find f of 0, I get undefined, and that's because I would be dividing by 0. Actually, 0 over 0 if you try direct substitution. But you can see as I get real close to 0 for x, that the y values get closer and closer to, well, here's the actual value, 1/6 is a decimal, 1.6666 repeating. Question is, how do you find that limit algebraically? And that's what I'm showing over here. Okay, and when you see typically a radical minus a constant or a radical plus a constant, what usually works is to multiply numerator and denominator by the conjugate of the expression that contains the radical. The square root of 9, x plus 9. Oh, this is supposed to be an h. Sorry about that. Plus 3, the opposite sign. The reason is because the product of these two factors, this is supposed to be an h also, is a difference of squares. And so this is like a minus b times a plus b gives you a squared minus b squared. So when I square the radical, I get h plus 9. When I square the 3, I get a minus 9. That new numerator becomes an h. In the denominator, we have this h times this factor. And when h approaches 0 but is not equal to 0, we can cancel out these h's. And that gives us a 1 in the numerator. And now we try direct substitution. That is, put 0 in for this h. And we get 1 over the square root of 9 plus 3, which becomes 1/6. So that indeed is the limit of this function as x gets closer and closer to 0. You can get as close as you want, but you'll never quite get there. Okay, there you go. Hope that helped. If you have any questions, post a comment.